That's on the first Thunder. Oh, I mean, there's plenty of math involved in Factorio. Hope both are doing good today, though. Thunder, do you have anything for me today, or you just chilling? Math 2/3 time. Hey, Eldritch. Hey, Bode. A white rectangle? Hell yeah. That's math. You do have a question? All right. Feel free to hit me up. Yeah, sure. Okay, there we go. YouTube stream's up. I'm doing good too. It's getting hotter, and that's making me not want to think or do much of anything, but I started the stream anyway, so here we are. Oh. Thank you for the 10 bits. Maybe penniless, but you're not bitless. And I'm doing good at Eldritch. How's it going for you? You get 60 problems for physics homework? Oh, geez. Going right to the bed, Eldritch? Yeah, I get it. No worries. Thanks for popping in and saying hi like usual. Today you less suffer? Okay. But, you know, that's better than more suffering. Why can't you only integrate something like 1 over 2x squared plus 3x plus 1 with partial fractions? Magic runes. So let's try your idea, and I think the best thing is to try it, and you'll see why not. The answer is the chain rule is going to mess us up there when we get du. 2x squared plus 3x plus 1. And the one, oops. The use of that you're suggesting is ln of the denominator, right? Let me go read back chat to make sure I'm getting that right. Yeah. So, I mean, there's nothing, it's valid to do this, it just won't be all that helpful. You could absolutely do a U sub like this and proceed from there, but you're going to have to end up doing some other sub and basically going to end up getting back to partial fractions. So when we take the derivative of this thing, we have an ln on the outside, so we do 1 over the inside. And then from chain rule, we derive the inside to get 4x plus 3 dx. And so when we go to plug things in back in the integral, we don't have any u's directly. This 1 over 2x squared plus 3x plus 1 will cancel with that 2x squared plus 3x plus 1. But we end up with this 4x plus 3 that is going to go in the denominator. The u, importantly. The variable of the integrand no longer matches the variable that we're integrating in terms of. So we can't, we have to keep rewriting this until everything's in terms of u, or yeah, then we kind of just have to do that. And we do have this relationship between u and x, but good luck manipulating this equation to isolate a 4x plus 3, basically. You could do like e to the power of each side. E to the u equals 2x squared plus 3x plus 1, but that's a u, not 4. But good luck getting, like, we can't just isolate x in terms of u here and plug it in for that x there. So we just kind of get stuck. It's u over 4x plus 3. What do you mean u over 4x plus 3? Oh, I mean when I sub it in here? Well, u is ln of the denominator, so there's nothing, we don't have ln of 2x plus 3x plus 1 anywhere. We could say that's e to the u, But the issue is we still have this thing to contend with. Like, let me actually not be lazy and manipulate and isolate dx. 2x squared plus 3x plus 1 over 4x plus 3 du equals dx. So if we take that dx and we plug this in, hey, it's G1. Four x plus 3 is not a constant. U is a function of x. These are... you'd be right if there was like... Wait, let me write this thing back. There is no u in the numerator here. It just... we never get it. And x is not a constant here because x depends on u. Like, these things depend on each other. If it was like an a or something there, sure. Or, you know, like something that's completely out of the blue, like not related to x or u at all. But x and u do have a relationship that we defined here, so it's not quite that simple. And I see you redeem Brian, so I'll look at it later. Like, you could pretend like x is a constant and get something, but it won't be right. Like, if you derived it back, it wouldn't match. There might be some crazy trig sub you could do or something, but partial fraction is probably the most direct way, unfortunately. Yeah, like you could complete the square and maybe try to do some kind of like tangent sub or something. I don't even know if that's going to work though, to be honest, so. It might be okay for like a quadratic like that, but if you have like a quartic or a cubic or something, trig subs are probably either going to be super complicated or just flat out not work. 1, 2, 3, 4 times 900 plus 1, 2, 3, 4 times 90. Is it just converting 1, 2, 3, 4 from base 9 to base 10? No, that's not it. Never mind. That's some weird, like, I don't know. I feels like it'd be the base of a number, but I don't know how you would call that. It's like base 10, but with like a constant 9. Yeah, oh, it's 1, 2, 3, 4 times 1,000. That's the trick. So it's 1, 2, 3, 4 with 3 zeros. Okay. Yeah. So what is that? 1,234,000. Yeah, and that's the answer. 1,234,000. Why is that little thing there? Can I make it not? Okay, cool. Why do you even have this stupid math forms thing in my bookmarks still? I never check that. Same with Quora. We're not going on Quora. Yeah, I got it right. Yeah, Jed, that's kind of the question. I've never enjoyed trying to dig through Reddit or Core or any of those forums for math questions or Stack Exchange. I just can't do Stack Exchange. Hate. Because it's just like it's so lame when there aren't questions out there, or if I figured out a problem, then 10 other people beat me to it. I've just been genuinely enjoying doing this studying stuff, so yeah, I'm sorry that you like getting questions from like online more, but I don't know, it's always been like a necessary evil for me until there's enough questions from chat to fill a stream, which probably isn't still gonna happen for a long time, but yeah, that's the part that I feel bad about, Jed, because like I don't think you know much about like either things that I've been studying. How about this? We'll at least like speedrun and look through, see if there's anything, but I really hate like the streams where I spent 2 hours just desperately looking through forums for a question to answer. I'm over that. Oh yeah, fair. What is this T thing? I don't know how this like bearing stuff works in this situation. I don't know what T means. I don't know how we're defining the bearing from boat B of boat B from boat A. Probably from the north. The answer is supposed to be 126 degrees. Okay, so I can see the right triangles you would make with 520, and then you have 2 angles for each boat. So that's enough information to solve a right triangle to figure out the positions of these things. Oh god. Yeah, just please give the mark scheme at the same time, I guess, Thunder. I really don't feel like dealing with bearings right now. I think I could do this problem if I can. I mean, I can do the math behind the problem. I just don't know how they're defining certain things. So we could assume that's like 600 degrees from the north. I assume going counterclockwise. I could end up solving the problem with that assumption just to find out that it's actually something else, though. I don't know, so Jed, if you're able to like get that one, I'll like try it, but I don't know, I'm also just feeling lazy today because it's just way too hot. 600 degrees, what are you making? And you can cook pizzas at pretty high temperature like that. Some pizza sounds good. Oh. Whew. I don't know how to use price index to calculate stuff. You only need help with part E. Um, can I show this PDF on the stream, Thunder? I don't see anything identifying in this. 100%? Okay, cool. Three watch streak. Ooh, thank you. I had a butterfly when you were a kid. Its favorite subject was mathematics. Oh my god. Hey, Skirtle. Oh, dude, that email was so adorable. You're, you're, I can't talk, but you're crushing it with those things. God. I can say thank you, I worked hard on that one. Oh, it came out great. You're good at drawing. Young's modulus. I feel like I've heard Gold talk about that. Isn't that like it's something about like the breaking point or like the stress point or the shear point or yeah, something under tension. The ratio of stress, force per unit area, applied to the object and the resulting axial strain, displacement, or deformation is the linear elastic region of the material, or in the linear elastic region of the material. Okay, so basically for each unit of stress, how much displacement do you get? Hey, AS Gaming Bros. Only one cup of coffee, what will I drink? Typically with wires, okay. So E is Young's modulus in pascals, sigma is the uniaxial stress in pascals, which I think that's just pressure, I guess. Yeah, force per area, pressure, okay. They use the different types of epsilon? That's not cool. BYJUS. It's the strain or proportional deformation. So you're on right now. It's a tech education startup at the P. Really? Holy crap. I did not know that, Viv. And sigma E is force per area. Epsilon is the change in length over like its natural length, I guess. Okay. Yeah, that's it's quite the dip. I don't even know what the site is. Like I look at it all the time when I Google math stuff. I've no idea. It's just like a oh, they have a bunch of resources, I guess, for learning like for specific tests. Huh. It's only based in India. Oh, okay. That's kind of cool. Figure 1 shows an apparatus used to investigate the bending of a beam. A traveling microscope is inside this thing. Fixed part of the Vernier scale. Moving part at that scale. Horizontally on rigid supports. The distance L between the supports is 80 centimeters. Traveling microscope was positioned above the midpoint of the beam. Focus on the upper surface. It's a microscope that travels, clearly, Thunder. No, yeah, I assume it's literally, it's like, it's, I don't know what the purpose of that would be either, because, like, I assume a regular microscope can't go fine enough to look at, like, the actual atoms. It's like an electron microscope, but, like, maybe, I assume it's just used as some kind of visual measure of the displacement. No idea how, though. Okay, let's just skip straight to part E, what you were asking about. We're probably gonna need to go back through some of those other ones. Student C performs a different experiment. A mass M is suspended from the midpoint of the beam. Magnification, classification? Okay. The vertical deflection S of the beam is measured for different values of L. Wait, yeah. Yeah, this is E, right? Do you want to talk about D instead? Okay, no worries. Okay, so I assume L is like the extension of that like traveling microscope thing as it pushes down on the beam, and then, well, show the log base 10 of S over M. Yeah, we should maybe scroll back up and see if they define it, because I already forget. Oh, hey, there's an S. So yeah, so S is the displacement from the beam's natural position versus, or S is just like the displacement of the beam from its natural position, I guess. That's helpful. And, oh, L is the distance between the supports. Okay. So in part E, student C is varying the distance between the supports, L, and seeing what the vertical deflection of the beam is. And this is shown on a logarithmic scale, and we're dividing out the mass for some reason. State what this shows about the mathematical relation between S and L. You do not need to do a calculation. So the log of one value scales linearly with the log of the other value. I think that means my instinct is that they'll just scale linearly if they're not logged. Like you would also get a linear relationship if you did into a logarithmic scale. That's my assumption, but maybe we should look at what the marking scheme says. I don't see the answer to part E in the images you sent me. I see A, B, C, and D. Do not. Oh, okay. Cool. Thank you. Yeah, this is definitely not something that I know offhand, so that's why I'd rather just look at the answer and try and reverse engineer that. Determines that SNL are linked by a power law. I guess if there's a coefficient, it's, well, I don't know. Oh, okay, yeah. Thank you. Let's bring up that better image. Yeah, this is like more towards engineering, I guess, but I don't know where that line starts and stops, I guess. Identifies that S and L are linked by a power law. S is equal to some power, or S is proportional to some power of L? Really? I guess if there's a coefficient. Oh. Oh. Yeah, they really pull that cubed out of their ass, don't they? Why would it be cubed? And why don't they use this cubed anywhere else? Maybe they use it right there? No? Yeah, how do we get cubed out of this thing? Is it based off the slope of this line? Well, just to show the power, like, how do we know what power, though? S is proportional to L cubed. So if we took... minus 1.7 minus 0.15. The beams and the distance between them and how they bend. Yeah, what this graph is saying is the farther apart your support beams are, the more bend you get. But it's not necessarily like a one-to-one relationship. It could be like exponential or something like that. Yeah, it seems like they're doing a few like variations of the I didn't look through AB like the previous ones that closely, but they might be doing different like variations here. So what is this? Minus 0.151. I just want to get the slope of this line to see if it does come out to be 3. So I'm just kind of spitballing here to see if I can get anything that matches. And that's, I think it's they hung a mass halfway through the beam, and I think it's the mass of that. Rise over run. So yeah, 1.7 will be on the top, minus 0.151 on the bottom, but we need to get a second point here. So we have minus 1.8. Wait, if this goes from 0.15 to 0.20, and there's 10 tick marks between, how much is each tick mark? I messed this up. That must be minus 0.175? halfway between them. Each one of these is maybe one less 0 on that viv? Or maybe you're right. Two is right. See, that'd be 0.0155, 0.016, or 0.16, 0.165, 0.17, 0.17. Okay, yeah, okay. So if we minus 1.8 do this graph, and then 2 before 0.20 is minus 0.19. Okay. Minus negative 1.8 or minus negative 0.16, and I gotta edit that 151 because it's 155. Sorry, 19. Ugh. That's not 3. I mean, you could round it to 3. That's a crazy rational number right there. I was trying to figure out the scaling, the scaling for this. I just wanted to get the slope of this line to see if it was anything particularly meaningful. Because if we got 3 exactly, we could pretty reasonably conclude that's how they got the 3 there. But this is rounded. Like it's only 3 if you round it, and I'm not so sure about that. The first point was wrong. 1.7 and 1.5 or 0.155. I think that's okay. No, that point would be on the right side of this, I think. Yeah, because we're in the negatives here. S is proportional to the cube of L. How do we get that? You got 4 for the slope? I feel pretty confident that it's my disgusting thing. Either way, these answers, it's probably not as simple as the slope of the line. Or is it? I'll say it could be the slope. If they just rounded it. My disgusting creature. What points did you use, Thunder? Actually, the more I think about it, the more I think it is the slope. End and start? Probably not. Estimating that's a little bit hard. Talos, thank you so much for the 5 months. You know what? And thank you. Not enough people call me hot. I appreciate you. My hair is red. There you go. It's like I'm on fire. Yeah. Okay, well, the point up here is a little bit hard. It's like minus 1.3 for y, of course, but then we're between two tick marks. We could just guesstimate it. Oh god, 0.025? Is that halfway? Yeah. All right, I'll try it with your 2 points, Thunder, in a strictly parasocial way. Just use 0.025? Yeah. You pull the 4.3 out of your ass and you get 3. That's my kind of math. Minus 1.3. And then minus 0.025. All right, now we need our second point, which you used the first one for. So minus 2.1 minus 0.3. Minus negative 2.1 minus negative, what was that, 0.3? No. Is that minus 0.285? No, yeah, you're right, Viv. Minus 0.29. Dude, math with negative numbers is hard. Okay, that comes out to be 3 as well. That's weird that we get different values. When I think it... Is this a perfect line? I guess it's not if we're getting different slopes at different parts. I guess we did, this is like an estimation. Like, we can't tell exactly what points this line goes through. That seems like a kind of a big difference, right? I mean, I guess it's 0.3 or like 0.25 off. I think I'm willing to chalk that up to having to eyeball the values. Because they are both pretty close to 3. And I think the point is that if these two values make more or less a line, you could this just kind of meets the bone, but if you know that log base 10 of s over m equals, because this is your y value basically. The slope of that line, we said it's around 3. Your m, and your log base 10 of L over m, right? Which is your x. Trying to make the equation of this line, but things are kind of like logarithmic, so it's not quite as clean. But if we were to try to solve this for s, you'd raise each side to the power of 10. You get s over m equals 10 to the 3 log base 10 L over m. And then the 10 and the log base 10 can cancel, and you would get L over m cubed, and that would get us to that L cubed. The m, I don't know why, you can just ignore it. But I think that's what they want. I think that's how they get this. How would a student figure out the slope? I think doing the same thing we did and just eyeballing it, and hopefully they're allowed to use a calculator. Wait. You do not need to do a calculation? How do you get this without a calculation? It's 1 mark. So this is the one that I did at first, Thunder. I can show the one that we just did with the first and last points, though, if you want. Let me zoom in. First and last, yeah. Say no more. Well, what's the easy way, Viv? I expect you to just eyeball the slope? Like, you could guesstimate it as saying your y's range over 0.8 and your x's range over 0.3. Pay your examiner, that is the easy way. But doing 0.8 divided by 0.3 is still a calculation, isn't it? What is 0.8 over 0.3? $2.6. I mean, that would round up to 3, I guess. And like these seem like calculations to me. Do they not? Well, I don't know how you would know what things seem to me, but hey, Hajar? I'm probably saying that wrong. I'm sorry, but welcome in. Oh wait, possible answers are S is proportional to L to the n. Oh, this might be enough, I guess. They're listing off a bunch of different possible answers here. Maybe you can take any one of these lines. And so they're including this L cubed thing in case a student went through the trouble of getting the slope. But this first answer might just be enough, and like this third answer looks pretty equivalent. That would make sense, I guess. And any one of these down here are slightly wrong for some reason. Okay. See, I mean, I think this is pretty reasonable to get. How do you know they're linked to the power? For the exact same, like, for the calculation that we just did on the board there. If you know their logs are linked by a line, you can make the equation for that line, basically. So you end up with S being proportional to some power val. Hey, Jumpa. I've been into Calculus 1, but I feel like I quite don't understand what a limit actually is. Would you mind defining it? That's a tricky... Okay, so Jumpa, let me ask you for clarification. Are you talking about the formal epsilon delta definition of a limit? Which I don't think you are, but I want to make sure we're on the same page. And if you haven't heard of what I just said, epsilon delta limit, I would just say your answer should be no, because you hopefully don't have to worry about that. But some calculus classes do make students worry about that, so I'm just trying to get a sense of what you're... No? Okay, good. That makes the task a lot easier. Hajar, you want the application for math? I'm not sure what that means. I need some more information. So yeah, okay, that's good, Jam. But let me wrap up this question with Thunder, and then I'll try to explain to you what a limit is. Seek a higher power instead. So yeah, Thunder, I think the explanation for why they're linked by a power is for the reason that I wrote on the board. You can make their logs match the form of a line. And then if you solve it just for your s, which is like your y, yeah, because their logs are linked by a line, they must follow a power rule. And that's just like a rule that you can remember, I think. Or they're linked by like some power. You can't just assume s is directly proportional to L. It could be L to some power because these logs are involved. If the slope was exactly 1 of that log line, I think you'd be okay. You know, actually, that kind of makes sense. The slope here is 3, and they're linked by a power of 3. Yeah, this is okay. This is making more sense to me the more that I talk about it. Of course, that doesn't help you, but let me. Oh, how I went from this to this? I did 10 to the power of each side. 10 to the power, 10 to the power. Because 10 to the power of log base 10 means this part here like moves down. And it's a little more complicated over here because 10 to the power of this log thing, this part will move down, but that 3 that doesn't have a log stays in the exponent. So it's using some exponent and log identities there. From the second line to the third line. I rewrote this part as 10 to the log base 10 L over M in parentheses with the 3 on the outside. And then this part just inside, the 10 to the log base 10 cancel. And you get just L over M on the inside. But of course the 3 stays up top. Awesome. Wasn't so bad after all? Yeah. The answers are simple, but actually understanding why that's the answer isn't, so no worries. All right, so Jampa, let's talk about what a limit is. The first thing I'm going to do is, since you say you're taking a Calculus 1 class, I'm going to show you my favorite website for everything calculus. It's Paul's Online Notes. I love this site. And they have sections on Calc 1 through Calc 3 and even differential equations if you go that far. Their Calc 1 section for limits, I'll drop a link to it in chat. But I'll give you a little talk about what a limit means. Let's go to Desmos, I think. Well, we'll start off in Desmos. We'll have to get some examples later on. So let's start off with like the easiest version of limit to evaluate. Actually, Jampa, are you still here before I go on a whole rant? Maybe you stepped away for a second. I don't want to. I want to make sure you don't like miss a part of this. You are here? Okay, cool. Just want to make sure. Okay, so the easiest version of a limit to get is when the function is defined at that point. Well, yeah, when the function is continuous and it's defined at that point. So if we have a parabola here and we want the limit at, say, x equals 2, so at like this point right here, we can literally just plug in 2 for x and we get our answer. And so that's kind of like the easy case of limit where there's nothing that tricky going on. But of course, you're probably encountering much harder situations for limits to evaluate, which we should talk about. So if things aren't continuous, the limit may or may not exist. And that happens a lot with rational functions and like piecewise functions. And so maybe it'll be a little bit easier to draw out my kind of base example on the board here. So if we have y equals x squared, and we want the limit as x approaches 2 of x squared because x squared doesn't do anything weird, we can just plug the 2 directly in to get 2 squared equals 4. But kind of a graphical idea for why this works, which I'll just quickly do a sketch of it on the board here. 1, 2, 1, 2, 3, 4. That's terrible scaling. Oh my god. Just ignore it. I'm not going to scale the y because that's not the important part. We don't need that accurate of a graph here, but the idea is that x equals 2 is right there, and the idea that we can kind of apply here is that imagine getting close to this point x equals 2 from the left and from the right. So you have to consider the area around x equals 2. And they both point to the same thing, which is 4. So that's why this is a nice case where we just get to not think too hard and plug in x equals 2 directly. Yeah, the tricky thing, that's kind of like the most important idea for them, I think, is thinking about the area around that point. So let's get a little bit of a harder example here. Let's use a rational function, I think. So let's say we have y equals x plus 1 over x plus 1 times x plus 2, maybe? Well, actually, yeah, okay, this works. So this is a rational function because it's a polynomial over a polynomial. And the thing that many students see right away is, oh, we have an x plus 1 and x plus 1, let's cancel them. And that's okay to do, but we're still not allowed to have x equals negative 1. Let me actually write it over here. And so in this problem, we're going to be interested in that limit as x approaches negative 1. Over x plus 2. So we can do that same cancellation. Negative 1 over x plus 2. Because if we try to plug negative 1 into this initial thing, we would get negative 1 plus 1 is 0, and dividing by 0 is bad. So we do have to do this cancellation. We want to just plug it in directly, and it is okay to do here now. We would get negative 1 plus 2 is positive 1, which is just 1. So let's see why that works graphically. So the graph of 1 over x plus 2, let me make sure that's going to be shifted to the left by 2. So 1 over x looks like that, but we're shifting it to the left too. So we're going to have a vertical asymptote at x equals negative 2. And we'll have one curve there and one curve here. But this graph is only valid when x is not negative 1, because we came from this function here, which is a really weird thing that took me a lot of time to get used to. But since x can't be equal to negative 1 because we came from here, we have to remove x equals negative 1 and have a hole there. So I'm drawing a little circle to symbolize that the function isn't defined at that one point. But we can still apply the exact same idea of how is the function behaving around this point where it isn't defined. If we come at it from the left, we're still getting pretty dang close to positive 1. If we come at it from the right, we're still getting close to positive 1. So even the function itself isn't defined for negative 1, we would say the limit is still, it does still come out to be positive 1. Now there's a third situation. So this is called a actually, before I move on to the third situation, this is called a removable discontinuity when you get a cancellation like this in a rational function. Uh, the limit for these will pretty much always exist. Well, yeah. For like a rule that's continuity like that, it'll exist. It'll just like a little hole in the function, but the function is still behaving pretty well around that point. We're gonna talk about like infinity and stuff like that, but let's just deal with finite stuff for now. So there's a third situation before we get into infinity that we should talk about, which are piecewise functions. So if we have y equals what function should I give here? Let's say y equals x when x is greater than or equal to 0, and y equals x minus 1 when x is less than 0. And we are interested in the limit as x approaches 0 of this function. So I'll just say of y to keep the notation simple. So we notice in this piecewise function, we have a breakpoint right at 0, and a graph here can really come in handy for figuring out what's happening. So when x is greater than or equal to 0, we have just y equals x. So over here, with a solid dot to symbolize that it's or equal to 0, I'll just draw y equals x. But then when x is less than 0, so on the left side of this, we have x minus 1. So -1 is the y-intercept, and I'll draw an open dot here to say that it's strictly less than and that 0 isn't included. And so now, if we apply our same kind of left and right rule around x equals 0, well, up here, if we're coming from the right, it looks like we're headed towards 0 for y. But as we come at it from the left, we're heading towards -1. So these two are in conflict. They don't agree on what this limit should be. So we'd say that the overall limit here does not exist. So people often say D and E to say it does not exist, because these two sides can't agree on what that limit should be. Now, there is such a thing as a one-sided limit, which I'm not sure that you've gotten to yet. Unless you say otherwise, I'll just skip over that concept. Do a proof writing stream. Oh, proofs aren't my strong suit, Poop, but I agree that they are very tricky. And so if you're not comfortable graphing things like the way that I just did, another way you can do it is to plug 0 in for each of these and see if they agree. So I'll show it like this. If x equals 0, we just get 0 there. But if x equals 0 here, we get 0 minus 1 is -1. So because these things don't equal each other, the overall limit doesn't exist. Actually, now just because it's piecewise doesn't mean the limit can't exist. If these 2 points, or if these 2 parts of it happen to just meet each other right at that breakpoint. So if we had like a y equals x when x is greater than or equal to 0, or -x when x is less than 0. Without even graphing, let's just do the same trick here with plugging it in to each thing. And of course, we're interested in the limit here as x approaches 0. If we plug in x equals 0 up here, we get 0. If we plug in 0 right here, well, -0 is still just 0. So here they actually do agree with each other. And we can say that this limit does come out to be 0. So just because it's piecewise doesn't mean it never exists, just means you have to be careful with it. Hey, Optimus OP. Oh shoot, there's a bit more that I want to say about limits. Let me just catch up with chat though. Optimus OP over on Twitch. Have you done Fourier series? Only barely. I don't know very much about them. The best person to ask, I think, would be Meriwether or Mark, who I think is more experienced with them. And hey, Ranxito Imparable, you just entered here and you need help to solve the integral x secant x. I can work on that after this, if you're still around. This is cool. Is this calc? Yeah, this is like how I talk about limits to a Calc 1 student. You finished Calc 4. Oh, nice. And Carolyn Ho, hey. And also hi to Ranxito. I see sick you're doing this. Oh, well, thank you. So you've done them a lot this year? Yeah, I technically had done them before, Optimus. I'm just very out of practice. Yeah, no worries, Jampa. So it's kind of like the basic rundown of limits for when things are finite. There's a whole kind of other world when you involve infinity. Do you want to hear about that too, or are you good with what you've heard? Or like, is that all, I guess? So there's like a whole other like set of situations we could talk about when infinity's involved. Oh, log base 0.2 of x minus 1 squared greater than 4? Are you asking to solve that for x? The whole, yeah. The entirety of abstract algebra real quick. Unfortunately, I can't. There's a streamer over on Twitch is doing an abstract algebra reading group though. Penn Center. From this list of math streamers. Okay, so I think I can solve that, Carolyn Ho, but I want to hear from Jampa if they want to hear anything more about limits when infinity gets involved, and then Ranxito asked that question about x secant x and the integration of that. ln of 1 is 0. Oh. Okay, I'm glad I plugged this thing into Wolfram Alpha. I said that the integral of x secant x is not easy, Ranxito. I probably can't do this. And depending on the class you're in, you're probably not expected to be doing this. If Wolfram Alpha gives an answer that's this crazy. What's the worst integration method? I mean, the most annoying one is partial fractions. It is good at helping you integrate stuff, but it's the most annoying to do, I guess, depending on how you want to find worst. The antiderivative one? I mean, isn't that every integral? Finding the antiderivative? So yeah, Ranxito, I would also need help to solve this integral, I guess. It's not a trivial one to solve that you would encounter in a normal calculus class. You like partial fractions? Well, I'll give all my partial fractions problems to you then. We'll both be happy. Yeah, Carolyn Ho. I guess we'll do your log question. So it sounds like Jampa's good with limit talk, so. And sorry, for anyone who's new around here, I dual stream to Twitch and YouTube, so if you hear me talking to someone who's not there in the chat that you're watching, they're, you know, either on Twitch if you're on YouTube or on YouTube if you're on Twitch, so. All right, so let me copy down the problem that you wrote and tell me if I'm interpreting you right. Like that? Okay. Well, I'd say we can start by square rooting each side. And that's safe to do with an inequality because y equals root x is always increasing as a function. So that's kind of like the rationale that you can use for whether doing something to an inequality flips it. If it's always increasing, you can safely square root each side and not have to flip your greater than sign, or that's a less than sign. Well, no, greater than. Sorry. So greater than 2 if we take the square root of each side. Oh, do we get a plus or minus? How does the graph of this thing look? We might actually get a plus or minus. Wait, this... It's usually more difficult to integrate if you're talking about single variable stuff. Differentiation, I mean, yeah, I would say usually integration is harder. The square is above the point 2. Oh, it doesn't make a difference, no. It's just a difference in style. How does this thing look? Okay. We don't need a plus or minus because it's not defined for... Oh, of course, yeah, it's not defined for negative x's. Okay. That's a cool looking graph, by the way, but... Okay. So I was debating if we need to put a plus or minus on these because we square root each side, but I don't think we actually have to because log of 0.2 of this thing is always positive anyway, so we'll never get any solutions involving negatives. Well, or at least like we don't need to also do like less than -2 or something weird like that. So what we want to do now is we want to deal with this law, with the log base 0.2 here. And we would do that by doing basically 0.2 to the power of each side. But a little side note over here, y equals 0.2 to the x, that's an exponentially decreasing function, something like that. So it takes I'm so unstable, guys. Thanks for the follow. Hey, Rumesa. And welcome in, Unstable. Hey, $10. I mean, like when you have one of those rules that require you to derive under the integrate. Oh, Feynman? Yeah, okay, that one's a crazy technique, yeah. So y equals 0.2x is a strictly decreasing function. So it takes very large values of x way out here and assigns them to a very small number. And it takes, and basically the lower the number is, the further you go left, the bigger number it assigns it to. So if we're going to do 0.2 to the power of each side, this inequality is going to flip. So what we get is 0.2, oh my god. 0.2 to the log base 0.2 x minus 1 less than 0.2 squared. And now 0.2 to the power of log base 0.2, that's a cancellation, and this x minus 1 part comes down. So we get x minus 1 is less than 0.2 squared. We can just do 0.2 squared actually. 0.2 squared is 0.04. Now we can add 1 to each side, and we get x is less than 1.04. And let's verify that graphically. Let's see where they, oh! So I got less than 1.04, which is right. I missed an answer though. We should have gotten x is greater than 26 as well. It must have to do with that square rooting, I think. Why? Do you teach GCSE maths? I'm not that familiar with the actual curriculum of GCSE, but I think it's all at the level where I can figure it out and help you out with it. I'm American though, so our tests are just like different, but I'm pretty sure I can handle it. And my Thursday is good Fenbox. It's super hot today, so it's a little hard to think, but it happens. I know what the 33 over 32 thing was, or the 26 over 25. Hey, SPQ. So yeah, Carolyn, no, I'm trying to figure out where I went wrong here. I'm not sure. I only got half the answer though. Hey, Tiger. How much calculus have I done? I have a bachelor's in applied math, so I've done up to like multivariable calculus. Yeah, I don't know how I get this answer on the right, to be honest. What does Wolfram say about this? Oh, true. I should have put a lower bound on that. It depends on how you think, I guess. Divergence I'm kind of aware of. I don't remember actually learning it. It was a few years ago, or it was like 5 years ago or something now, but rotor, I have no clue what that is. Triple integrals, yes, I did learn. Yeah, Carolyn, no, I don't know how you get that other answer if you can't, like, just like algebraically. It must be missing something, but I don't see what that thing is. Are there any questions from chat? Because I think I've gone as far as I can with this question that I've been working on. Rotor is? That might be called like a, or at least the way I learned it might be called like is that the Wronskian? Oh, they don't show it in a matrix, but like I did learn like about taking the double partials, putting them into a matrix, and taking the determinant of that. Wronskians for differential equations. What are the determinant for finding the minima or maxima of a function is? I learned that. I forget though. The online puzzle. Oh, was that the bug bite one? Yeah, poop. I know that. I don't know how you get it though. Or are you talking about like a different puzzle? Oh, okay. I guess so, sure. Yeah, links are turned on in Twitch chat. Okay, sounds good, poop. Can I please get this stupid thing off my screen? Ugh. Each card contains 8 symbols. Any 2 double cards in the deck share exactly 1 symbol. Wow. Okay, so you only use each symbol twice, I guess. Yeah, I'm terrible with combinatorics, so I'm not optimistic I'll be able to explain this, but maybe we can figure it out. A standard double deck consists of 55 cards and 57 symbols? You only need 57? Why don't you need at least twice the number of cards? You're only using each symbol twice if each card in the deck shares exactly 1 symbol. And they have 8. I feel like it's a pretty big constraint. Can you reuse the same symbol lots of times? There's like 8 symbols per card, and any 2 having exactly 1 of the same symbol. Those both seem like pretty big requirements. I assume that can't be repeated SPQ on the same card. Let me scroll down a tiny bit so I'm not blocking the problem. Well, okay, well, if I just accept this, I guess I'll need to make some examples or something of how this actually works, but I'll just read through the actual question here. Given number n, which is a prime power, it is possible to find a double-like deck where each card contains n+1 symbols. Really? More symbols than there are cards on each card? What? Did you give this problem to Ita, Toy Pie, or Zach? I feel like this seems a little bit familiar. Honestly, I'm not completely sure what the setup of this is yet still. I'm like you're saying we could factor that log problem? Subtracting the 4 over? Oh. Wait, is that... We do get the difference of 2 squares. I don't know where that 25 comes from. Okay, so Tiger, before I look at this more, let me fix what I did on the board for the log. So, Carolyn Ho, I think... There's a completely different way that we could think about this problem. Huh. Okay, so if I just restart from down here, this one squared greater than 4. So yeah, I gave up on this problem, but I think Fenbox figured it out. If we subtract the 4 over to the left side, log base 0.2 x minus 1 squared minus 4 greater than 0. This is a number squared, and 4 is 2 squared. It's a difference of 2 squares. We can actually factor this. And I think that's where the second solution comes from. Minus 2 greater than 0. So for this inequality to be true, these are both positive or both negative, right? And can we ever have a negative number? No, because this is always a positive number. Well, ooh, that could maybe be... Yeah, okay. This one is always positive. So we only need to consider the cases where each of these are positive. Greater than 0 and log base 0.2 x minus 1 minus 2 greater than 0. Maybe here, let me just like, I guess get to the bottom of this thing here, and then I'll look more at chat. And hey, Flexus, I saw you posted something. I'll look at it in a minute. Log 0.2 x minus 1 greater than 2. So now we do the 0.2 to the power of each side, which does flip our inequalities. for the reason we said before. So we get x minus 1 less than 0.2 to the negative 2. And log base, whoops. And x minus 1 less than 0.2 squared. And so this piece matches up exactly with what we did up here, which is why we still got the right answer of the first inequality. So that's x is less than 1.04. And then over here, that's where we get our second solution. So 0.2 to the minus 0.2. Yeah, that's 1/5. So you get 25. Aha. So that's not good. X is supposed to be greater than 26. For some reason, we don't flip this inequality, and I think it's because one of this is negative 2. Because if we're at x equals negative 2 over there, we get mapped to a big positive number. This is a really weird rule, or it's a really weird situation with inequalities that I'm trying to figure out. We have a positive number is greater than a negative number, and we do 0.2 to the power of that. I feel like it's right to flip this inequality. Does it get flipped back somehow, or like, did I have to flip it originally? Okay, well, we nearly got, I'm getting, it should be x is greater than 26. I'm getting less than, and there's something that I'm missing with the inequality flipping here. Let me catch up with chat. You don't fucking know without log problem. Yeah, so I guess we did need the plus or minus 2 back when I was saying that when I originally tried the problem. I still would have made the same mistake though, so I'm not sure what to do about that. It could be that 0.2 is 5 to the negative 1. Log base. I don't know if it's the exact reason that you're saying, Carolyn Ho, but we do end up with a 0.2 to the power of negative 2, and that can just be 25. That's what it's supposed to be, Optimist, but I can't figure out why. Like, I can't actually justify it in my work. Are we talking about like a change of base formula? Oh, I guess a change of base formula would work. You're right. Maybe that'll... This is really reverse engineering it. But if we want to, if we already know the right answer is x is greater than 26 for that piece, I don't know where I went wrong here, but we might get the right answer if maybe from this step we do a change of base. So we're talking about changing it to log base 5. X minus 1 over log base 1/5 5 greater than -2. No, we still flip the inequality. I don't think that fixes the flipping issue, at least. It is true. But you would get log base 5 x minus 1 over -2 is greater than -2. Wait, -1. And this inequality still flips when you multiply each side by -1. Denominator in the change of base formula looks wrong? Oh. It does look wrong, doesn't it? It's still -1 though. Like you still flip the inequality in a bad way. Kofu, thanks for the follow. That is a save though, because you figured out that factoring thing. I'm not sure how to bring it home here though. In Votech, I'm probably saying that wrong. Behind dividing the problem into 2 equations. Well, the logic is, I thought we didn't have to do that, and then I checked my answer and I was wrong. So now we're reverse engineering what it's supposed to be. I think in my work at the top, when I square rooted each side, I should have made it plus or minus 2 to be valid. This inequality does have 2 intervals for the solutions though, and we're nearly there, but not quite. But no, I did not spot to do the dividing into 2 equations on my own. Like I wouldn't have thought to do it normally. Where does that negative sign come from, Optimus? It just doesn't match the problem that we have unless you're changing the base again in some way. All right, yeah, Flex, I see the question that you posted. Well, yeah, sorry, Optimus. The next step would be to multiply each side by -1, but then the inequality flips, and we get the same exact thing as I got on the right side, with x less than 26. So there's still a mistake. I guess it's earlier on. I don't see exactly where that would be, though. Wipe out the inequality in the base logs between 0 and 1. I'm saying we do that because, well, it's not necessarily the base of the, it is the base of the log, but it's because when I do 0.2 to the power of each side, that's like 0.2 to the x is a decreasing function. So very large values of x get mapped to a very small number, and very small values of x get mapped to a very large number, was my logic. The symbol's ordered because it affects the answer. Oh yeah, I'm not sure at all. It's because I'm probably not going to come back to that problem, to be honest. In the first part, the problem is that the 2 can be... Yeah, in the work I did above, it should be plus or minus 2. And so in a roundabout way, we fix that in the work in the bottom half, but we're still not getting quite the right answer. It's nearly right, just it should be x greater than 26 rather than x less than 26. I was hoping this would be the same region. And that would be an easy justification for why we flip inequalities. So is this maybe a... this flipping thing isn't always true then, I guess. It's true if they're both... I guess it's true if they're both positive, so maybe you don't flip it when you do 0.2 to the power of each side. Huh. It's weird when you cross from negative to positive or back again. Hey, Phobos. Wait, you're just like ping-ponging that negative sign back and forth. Actually, wait, no, you drop it, and that from the second to last step to the last step, Optimus. I don't think that's right. For reasons that I don't quite understand, I think you do flip it in this situation when you do 0.2 to the power each side, and you don't flip it in this situation. In this case, they're both positive, where I think it works nicer, but this one is positive and this one is negative. And I think that means, for whatever reason, that you don't flip the inequality. That's my guess. The rules when you do and don't flip it inequalities, especially for stuff like this, are really weird though. So I don't fully understand why we do and don't flip it. You know what? It might be because of a kind of new year, so I don't know how you approach the problem. I think you would solve the problem putting those two equations equal to 0, calculate the whole sign for flipping points. Lightning and Neem, thanks for the follow. That might be a more direct way of doing it. Getting to where the flipping points are, and then just plug in points on either side to figure out if it should be greater than or less than. I do kind of like that technique. It's simpler to think about. In Federio, a fractional base name is multiplied by -1. And taking, so are you saying there's like a double flip happening, Federio, or I'm not sure about what you're saying. I think when there's like a fractional base, I think you do flip it when they're both positive, like on the right, but it seems like you don't flip it on the left. But yeah, Carolina, if you are still here, the approach that Kofu suggested is to not have to think too hard about this inequality flipping stuff. And you instead take this one and just let it be equal to 0, and take that one, just let it be equal to 0, and you solve those two things. And then once you get the solutions for x equals 26 here and x equals 1.04 here, you just test points on either side of those things and figure out where the inequality should be. So like over here, you test x equals like 27 and see if it's greater than or less than 0, and x equals like 24. And same over here, you test like x equals 1.03 and x equals 2 or something. You do have to have a calculator for that, I guess, but that's probably the way that requires the least thinking to solve this problem, which I'm a fan of not thinking. I mean, Optimus, I agree, but you're just kind of flipping the negative sign back and forth and doing a bunch of flips, and then the last time you just randomly drop the negative sign as far as I can tell. So I don't understand the work that you put there. SPQ, rating was valid, double deck corresponds to non-disjoint partition. Oh god, yeah. I'm out of my depth there. Weird notation denotes the Stirling number of the second kind. So, I mean, I guess this inequality is an interesting problem. It got us talking, but not easy. All right, we do have a problem from Flex that we have to do. Hey, Morphus, I'm doing good. How about you? So Flex Shakes, are you still here? I'll at you in chat in case you maybe have the stream on mute. Can we do an integral? I mean, do you want to give me? Well, actually, I mean, I guess the emphasis of the stream is homework help, Optimus. And I think you mentioned that you're pretty deep into calculus, so I probably can't help you with integrals. Likewise, that's good to hear, Amorphous. Awesome. All right, so thanks for hanging on, Flex Cheeks. Let's work on your problem here. How is this going to work? Just watching it? All right. Yeah. Sorry, Optimus. I prefer doing like doing homework help to doing challenge problems. So people do get a little crazy with the challenge problems too. So I get much more enjoyment out of doing like homework help, I guess. So if someone is in like Kevin's class and gives me an enroll, I'll do that. But yeah. So we need the exact value of log base 10 of root 500. So oh, huh. Okay, I think I see what's going to happen with this problem. One over 10 squared. The best viewers, I heard those are over in Phobos's stream. Minus a half, maybe, Finlock says? Where minus a half? I think I copied this problem down right. Oh, that's true, Phobos, yeah. Drop the ball again? Okay. 5 I still don't know what problem you're talking about, Funbox, to be honest. Oh wait, this is the answer. Okay. You're calling what the result should be. Okay. Let's see if we can get there for ourselves. So this is one where they want the exact value, and they probably don't want you to use a calculator. So what we need to do is we have everything is log base 10. So we want to play around with log identities until we ideally want things that are like log base 10 of a power of 10. It's like log base 10 of 1,000. Well, that's just log base 10 of 10 cubed. Oh my god. That's definitely how 10 cubed looks. So the log base 10 of 10 cubed is just 3. That's not something you need a calculator to do. So we got to kind of hope that things are going to be power of 10 after we play around with log identities up here. So looking at this log base 10 of root 500, let's remember that the square root is the same as an exponent of 1/2. This 1/2 log base 10 I'm going to leave alone for now because of what we'll see in the next step. And then this log base 10, 1 over a number is the same thing as that number with the negative exponent. So 1 over 10 squared is the same as 10 to the negative 2. In this, we'll be able to do directly because log base 10 of 10 to the negative 2, it's just negative 2. It's equal to. All right, so now the point of doing this thing with the 500 is that when you have log of something to a power, the power can come out front just magically. So this thing is equal to 1/2 times log base 10 of 500. And I'm just going to evaluate this to be negative 2. So where there's a minus sign there, and that can be negative 2, so I'm writing minus negative 2, but it'll turn positive. Okay, but from these two, I notice they have a common factor of 1/2 in front of each of them, so let's factor that out. Because I'm going to want to use an identity with these logs on the inside. +4, or sorry, +2. Okay, so if you have the same base of 2 logs added together, you can combine them into 1 log if you multiply the insides. So log base 10, 500 times 2 is 1,000. And 1,000 is 10 cubed. The way that I remember that is you have 3 zeros, so you just do 10 to the number of zeros. That's the cheat way to do powers of 10. So log base 10 of 10 cubed is just 3. So 1/2 times 3 plus 2, now we just have some fraction math we have to do. 1/2 times 3 is 3/2. We want to get a common denominator for 2/1 with 3/2. So we're going to multiply that by 2/2 to get 4/2. We end up with 7/2, which is not what Fenbox got. I hope this is right, though. (7/2)? Okay, cool. Thanks for the confirmation. Fenbox, yeah. That would make sense, Flex. Let me know if I lost you any stuff there. In Federico, maybe figure out the answer to that log problem. If x less than y, exponentiating 0.2 to the power is, or to the star, is the same as y minus 1. Bases greater than 1 do not flip sign. Bases less than 1 do. So I was flipping it, but it turned out to be wrong when one of them was positive, one of them was negative specifically. If they're both positive, I agree that's true. And maybe if they're both negative, it's probably true as well. So, but if one is positive, one's negative, that's where I was a little bit unclear. Like, I think you don't flip it, but I have a term saying why. Oh yeah, sorry, I saw you posted like where you were in your work. I should have probably addressed that, but I forgot to be honest. I got a little carried away forgetting a problem for myself. Looks like you had the idea though, yeah. You got to the same step that I did at a certain point. And actually, there's a couple of new faces around in chat. So if you are new to the Twitch math stream community, I highly encourage you to check out these math streamers here. Like, because I'm not the only one who does math on Twitch. So if you're looking for more like math streams, those are people I can recommend highly, as well as Phobos. Yeah, gold. Oh, we got a gold fan here. Hell yeah. So I just like to, whenever I see like some new faces, I like to kind of shout everyone out because it's a like cool community here. Chase the best. Yeah, he's awesome. No condition on X or Y. Yeah, it's more just from observation, or like in the problem that we had, I either missed a sign flip somewhere else in the problem, or when I had positive greater than negative, you are not supposed to flip that sign. So either I miss the sign flip somewhere else, or you don't flip it in that case, and I can't figure out why. Introduction to Calculus BC. Yeah, are you gonna be like taking it starting next like school year, like in the fall? Did you do calculus AB first, or are you coming in cold to BC? You just took AB? Okay, good, good. So if it's anything like when I was in high school, at least, which was 10 years ago now, which I don't like thinking about, but basically, the first semester of calculus BC is all of AB over again. So you're not going to learn anything new for the way that it was ran for my high school, at least. You're going to go back over like derivatives, related rates, and I think basic integrals is all that calculus AB covers. In BC, you do all that in the first half, and in the second half, you cover harder integration techniques, you cover series, and series includes like regular series and power series and Taylor series, and then the integration includes some like application stuff too, I think, and maybe basic differential equations. I don't remember that part, but what I would tell you to look at is Puzzle Line Notes is my favorite website for everything calculus. I'll drop a link in chat here. And what I expect you to cover in a calculus BC class is, I think it's going to be in calculus 2. Everything in this integration techniques section, maybe not in the comparison test. In applications of integral, probably at least the first 2, maybe the second 2, and probably not the 5th one with probability. And I think calculus 2 does some polar coordinate stuff, or I'm sorry, calculus BC. Yeah, and then I'd also take a look at, it's just like interested in taking a look at what the math even looks like. I think you would end with the series and sequences part here, which there's a lot to this. You know, we can actually look up calculus for AP calculus BC. That's probably a better thing to actually look at the what the website says. Oh, okay, yeah. Fembox would know. Okay, cool. So here's even all the topics that you'll cover. So you could like, ooh, it does cover differential equations. I think it's only gonna be the basic ones. Yeah, slope fields, Euler's method to approximate, separable. Yeah, this last bullet point will be a little bit annoying. The differential equations that you cover in calculus BC are not going to be. It's really just going to be integration, and like some like it's basically applying your understanding of the derivatives and doing some integrating. There are some annoying word problems that come along with it, though. Well, I actually personally like those word problems, but they can be annoying too sometimes. See, I would basically look through the, like, if you're interested to see what the math looks like, like look through this list for what you're going to learn. Even you do vector functions in BC? What? Interesting. Touch super light on a certain topic. Sure. So you're probably going to start off with doing, once you get to the new content, I think you usually start with doing harder integration techniques. So let's see what Paul's notes. Okay, so like integration by parts is a really like nice thing. Do you know what integration by parts is? I want to make sure maybe that's covered in AB as well, but I'm not sure. Like I'm thinking, we can just look through this integration techniques part and just like look for the first one you haven't seen before, and I can give you like a quick rundown on it. It's not in the calculus AB curriculum. Okay, but we were forced to learn. Okay. How about if you have to integrate sine to the power of 5x? Have you done that before? Yep. Oh, okay. You're getting you like your teacher is probably mean, I guess, if you're being forced to learn that much beyond AB. What about like this integral right here, root 25x squared minus 4 over x? You also know that one? This one is a U sub? No, it's not. It's not a U sub. This x on the bottom, it's not gonna cancel. We need to use trig here, actually. Funny enough. You do take x equals probably like secant or something. Oh, I called it secant. Yeah, so you do, it's like a U sub, but they sometimes use theta instead. You probably end up with some inverse trig thing. Oh yeah, it's one of those problems where you end up with like a tangent of secant or something. Yeah, so like you end up with a result that looks like that. So you're actually you for the integration part, you've learned a lot more than I would have expected. Let's maybe look at yeah, we can look at the application part, I guess. Like, I guess, yeah, if you want, do you know how to get the arc length of a function? Like the actual, like, distance this line covers? No, the optimists, they don't do partial differential equations in high school. They're just doing ordinary. Okay, so you haven't seen this before. Okay, cool. So, to get the arc length of the function, it's actually not all that bad. Oh, you're doing partial, yeah. It's basically just a formula. So if, oh yeah, that is a neat problem, Federico. But it sounds like Lightning has already learned at least some integration by parts, so I'd rather do something that's completely new. So like we can take this problem right here as an example problem. It's really just gonna be plugging into the formula, to be honest though. So with some of these applications of integral stuff, it's just plugging into a formula. It can be sometimes tricky to plug into that formula. Like I don't remember if it's AB or BC, but there's like solids of revolution that can get pretty tricky to set up. But arc length, it's a little bit of an easier one. So we want the arc length of y equals ln secant x. Optimus, thanks for the follow. Where 0 is less than x is less than pi over 4. Okay, cool. And so formula for arc length that I'll call L is equal to the integral from a to b of square root 1 plus dy over dx squared dx. So really, if you just plug in this formula, you get some kind of integral and you solve that thing. A and b are your endpoints for the arc length. So to plug in, we need to figure out what the derivative of this is, but it's not so bad. If y is ln secant x, dy by dx is this is a chain rule problem. We have ln on the outside, so we do 1 over secant x. Then chain rule, we derive secant x, which is secant x tangent x. The secants cancel, so we get just tangent. So we plug in tangent x for dy by dx. The bounds of integration are 0 to pi over 4. Root 1 plus tangent squared x, because that's squared dx. And I assume it's Pythagorean identity and it's equal to secant squared. I'm not even going to bother checking it because I assume it's... I'm just going to assume it's that because it's easier. And square root of secant squared is just secant. 0 to pi over 4 secant x dx. That's actually not a... The integral of secant x is something weird. Yeah, this is something you learn in calculus BC. Oh, thank you, Fembox. Yeah, ln secant x plus tangent x. Yeah, okay, so I think it's possible to prove it, but I'm just going to take Fembox's answer there to say that secant integrates to ln secant x plus tangent x. You evaluate it from 0 to pi over 4. Ln secant of pi over 4 is 1 over cosine. Cosine of pi over 4 is root 2 over 2. So 1 over root 2 over 2. It's 2 over root 2, which we can simplify. Tangent of pi over 4 is 1. Secant of 0 is 1. Tangent of 0 is 0. If we rationalize the denominator for 2 over root 2, you get just root 2. And ln of 1 is 0. So I say the answer, and root 2 plus 1 is a positive number, so the answer is ln, of root 2 plus 1. And that's the exact arc length of the function over those bounds. We were forced to... Oh yeah, I mean, I used to have that memorized too. But yeah, it's the actual, like, in the same way you can get like circumference of a circle, you can get the length of a function even though it's like curvy. Welcome to Marhalis. Yeah, I mean, with all of math, if you don't use it, you lose it. When I first started the stream, there were so many things that I had forgotten. Oh, and Federico's giving the chat a way to do it if you know complex variables, but I wouldn't use complex variables for the calculus BC test. I mean, yeah, Lightning, I say if you're worried about the AB stuff, you should be reviewing it in the first semester of your BC class. So hopefully that part will be okay. Fourth math course in uni? Ooh, good luck. But yeah, I'd say a lot of the integration you're going to learn is pretty... You just have to learn the tricks, and then it's not so bad. Learning the tricks can be hard, but normally students that I've seen stumble more on the series part. Because that's like it's a concept that I never learned until I took a calculus BC class. And series deal with sums of infinite numbers. So like you have to get used to summation notation and whether that sum of numbers can approach a particular number or shoot off to infinity or something. Yeah. So you figure out whether like a sum like this would converge or diverge, which is I actually personally quite like this part of calculus. It's pretty it's a little bit hard to learn for the first time though. The basic definition is that converge means it approaches one particular value. It's like a limit can converge too. And diverge means it either shoots off to infinity or it kind of like oscillates and doesn't approach one particular thing. Yeah, series for differential equations is really fun. Give us a quick example of a series. Normally start you off with like the geometric series or the harmonic series. Let me see. Actually, well, before we even get into like some series like that, like a pretty straightforward example of a series is, let's actually unpack what this notation even means in the first place. So summation notation. It's all based around this Greek letter, capital sigma. And how we write a summation is, I'll show two versions. One way is you give your index variable, which I'll call I. You say where this variable starts at. So I'll say I equals 1 up to some other number n, or I should put an actual number in there. We'll just say 5. And I'll do a basic example, or like we can sum I squared, I guess, just to give it a little bit of pizzazz. And so what this means is we start with I equals 1, and then we do I equals 2, plug it into this thing here. We do I equals 3, plug it into this thing here, all the way up to I equals 5, and we add all of those things together. So I'll start with I equals 1 because that's where we're saying we start. So we get 1 squared plus now 2 squared plus 3 squared plus 4 squared plus 5 squared. And it's pretty related to like the idea of a for loop in programming, if you've ever learned a coding language, but if not, don't worry about it. So that's some of the type of series you're going to be dealing with. You're going to be dealing with a little bit of a harder version of series, which normally instead of going to just one number on top, they go to infinity. And instead of I, they like to use n a lot of times. So like you might have the series from n equals 1 to infinity, and we'll use the example that Paul's notes gave of just n there. And so this is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus ... all the way off to infinity. And we're interested in, does this infinite sum of numbers equal one finite number? The answer is no. But sometimes the answer is yes for other situations. Jay Lockside, thanks for the follow. Hopefully physics homework. I can try BOD, yeah. I'm just going to talk a little bit more about series, and I'll take a look if you want to post it. So for this example of a series, we're going to say this thing diverges, as in it shoots off to infinity. Because, like, you know, we start off at 1, we add 2, we get 3, we add 3 again, we get 6, we add 4, we get 10, we add 5, we get 15. It just keeps on increasing more and more and more, and it's going to keep on increasing more and more and more. So we'd say it's infinity, or, you know, it diverges. But, and I think it's probably where I'll end it unless you want to hear more. It's possible for a series to converge if you have, say, like 1 over n squared. Here, the bigger n gets, the smaller these fractions get. So you're adding on smaller and smaller fractions each time. And that's how it's even possible for a sum of infinite numbers to become just one thing after a certain point. So this looks like 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, 1 over 4 squared. The numbers keep getting bigger and bigger, which means the entire fraction gets smaller and smaller. We're adding on infinitely smaller numbers, which probably isn't the best term to use there, but numbers are getting smaller and smaller to the point where they're not going to matter after a certain point, more or less. This is, the result of this sum is not something you're going to do in a calculus class. I think it's like pi squared over 6 or something. You can actually show it's possible for this infinite sum of numbers to come out to be just one finite number. This exact number might be slightly wrong, but it's something like pi squared over 6. No! Ah! Wait, what? I don't know what happened there. Okay, I don't know why the screen went black. Sorry about that. Yeah, that just took a nap. You're right, Penbox. Okay, but yeah, I don't know exactly when it cut off, but I was just ending with, if you have like 1 over n squared as an example of a series that converges, it's possible to have a series that converges to 0 as well. This one happens to be pi squared over 6 or something like that, but I can't remember exactly. Usually, you're not concerned with getting the actual number. You're just concerned with proving that a number exists, which is what we say is what we call convergence. Normally, it's really hard to find this number. It's actually pretty hard to find that number in particular. But we can show that it does converge to something and leave it something for someone else to figure out, basically. So yeah, it's kind of like my little impromptu introduction to the series and what it means to have a summation. We should take a look at Bode's problem. Let me know if you have any like questions or comments about it, though. Markowitz, you can do that. That would be called like numerically doing it, when you just try plugging in numbers and seeing how it behaves. The way you do it in a calculus class, you have the part that makes it hard is you're going to have like a million different tests. So if I like, open up Paul's notes and I go down the list here, there's going to be the comparison test, the limit comparison test, the test for divergence. You're going to have the integral test, alternating series test, ratio test, root test. There's a whole bunch of tests that you apply to figure out whether things converge or diverge. And which one you use in what situation is the hard part. The tests themselves, for the most part, aren't so bad to apply. It's just you were given a series and you have to figure out which one. So I personally enjoy it, but it's a lot when you're first learning it. Yeah, and series has some really cool applications in physics and engineering, because when a problem is too hard to solve, you can just use a series and get a numerical answer. It's like a cheat code for solving equations. Did I get Bode's problem? I did, okay. So Bode wants help with 10 and 12. Oh gosh. Oh, we did a tension problem like this with Thunder. Use series for derivatives. You can use a series for a differential equation. Oh, I mean, I can talk about that quick, but I do want to help out Bode. 'Cause that's a part of series that I think is really cool application. But if you have a like, you wouldn't use a series to figure out like if you have y equals x plus 1 or ln(x) or something weird. You wouldn't necessarily use a series for that. I guess you probably could like figure something out. The part where I've seen it is if you have something called a differential equation, which is something like y prime plus y equals 0, you can use series to solve this differential equation. And differential equations are cool because you're solving for a function, you're not solving for x. If you have to figure out what types of functions, if you derive it and add it to itself, become 0. In this case, it's going to be e to the negative x, but I don't want to get into that too far. Oh, you did differential equations. Okay. Well, since you already know a little bit about them, you'd use series here. You would assume y equals sigma. Oh, what is that? Sigma. From n equals 0 to infinity, I believe of like a sub n x to the n, something like this. You would derive it and plug it in. You can derive this to figure out what y prime is. A sub n x to the n minus 1. Plug these two things in up there. It might be n equals 1. And you can figure out what your coefficients are, which are a sub n, and that's how you would solve it. It's way more complicated than you would want to learn if you only know like the basics of differential equations, though. 3 derives in the same minute. the rate of these derives is off the charts. Proving derivatives? You probably could. It's normally not that hard to, well, to prove a derivative, like doing the limit definition of a derivative. No. I think it's a logical error because if you're gonna use a series to prove what a derivative is, usually you figure out the series based on the derivative of a function. So it'd be circular logic to use a series to prove a derivative when the derivative actually proves the series, I think. Like you could get something that would look valid, like it's called a Taylor series. How you can use a series of numbers to represent a function. So like you can find that e to the x is exactly equal to this infinite series here, but that relies on derivatives. Actually, e to the x is a special case where you don't need derivatives, to be honest, but normally, yeah, you need the derivative to find the series, so it doesn't make sense to me how to use a series to find a derivative unless you're just doing some like for fun like verification stuff, I guess. But I don't think you can actually prove a derivative with a series, I don't think, except for e to the x, which is like a special case because e is just a special number. Okay, but I really should look at Bode's problem, and I'm happy to talk about it more after we at least try Bode's problem. So I feel bad keeping Bode waiting more. Okay, so how do we get the tension in the rope? I did this problem like this once with Thunder. I don't remember what it's. I assume it's not as simple as. I think. So the tension in this part of the rope. What are you doing, camera? Why is this happening? I don't know why my camera is bugging out. I'm sorry about that. It's never done that before. Show me app code. So I haven't seen them type in a second, so I just make sure that they're around. So the tension from this way is 2 times 10 UR. Okay, cool. I'm probably gonna have to Google this to make sure, but let me say what I think, I guess, first. The tension from this way is 2 times 10 is 20. The tension from this way is 3 times 10 is 30. Oh no, I was gonna say you add them together and divide it by 2, but 25 isn't an option. Well, because I think the tension is split in two because the pulley like basically splits the tension in half. Oh wait. Ah. Oh, okay. This looks familiar. Yeah, lightning, that's the idea. I haven't heard that term Atwood machine yet. If I've done this problem, it's been a very long time, but tension T in the rope in newtons. T is equal to M1A and T in F minus T is equal to M2A. Okay. Well, they want the actual force, I think, so it's going to be, we want the answer in newtons. Femlux is calling that it's 24. Okay, so Femlux is calling the answer C. I'm slow and I haven't gotten there yet. Let's see if we can figure it out. Yeah, I bet this would be an easy problem for like Gold or someone. I'm just out of practice with my mechanics problems like this. Uh, 2 kg and 3 kg. So yeah, this mass is going to get pulled down, that mass is getting pulled up. So that mass is getting pulled up by the tension force. This mass is getting pulled down by, I guess, mass times gravity, the force due to gravity, and getting pulled up a little bit by that same tension force. So the overall force that we're interested in on this 3 kilogram mass, actually I guess we can solve for the tension first, because on the 2 kilogram thing, that's the point. Oh, we're finding the acceleration. Oh, okay. Wait, tension from this 2 kilogram thing, we get tension is equal to that mass times A. And then we know that the overall force on the 3 kilogram thing is equal to, I guess which way is up and which way is down? Like we can do the force due to gravity minus the tension. Is that how we're setting this up? Oh no, they get added. You took AP Physics 1? Yeah, you're probably better at this than I am, to be honest. Why is this F minus T is equal to mg? I can just go with it. Wait, I'm still getting this wrong. M2A. F minus T is equal to the second mass times A. Then what is F? Is F the force? Oh. F is the applied force. Okay, I don't have to get the setup of this, but I think this is the right setup, and we know that T is equal to 2A, and we're interested in solving for F4, so I'm going to add the T to the other side first. F is equal to T, we know is 2A, 5A, and then what do we do here? Is F mg? Or like, how do we get A? Like, are we saying that 3 times 10 equals 5A? Which means 6 equals A? Lightning got 2 though, and Fenbox agreed. So not force over mass equals acceleration. Yeah, I'm doing something wrong here. 30 newtons from the 3 kg mass minus 20. Okay, that's a much more intuitive way of explaining it, Lightning, thank you. Like, I was trying to follow the second exchange post did, but like... that just seems simpler. So yeah, if we want to figure out how fast, I guess this 3 kilogram mass is accelerating. So we can figure out the force on that as the weight of this thing due to gravity, which is 3 times 10, minus the weight due to gravity of that 2 kilogram mass, which gives us just 10 newtons. And we know that F equals ma, and m here for just a 3 kilogram mass is 3. No. Ugh. Why is that 5? I wonder why it doesn't feel like they should add, but I'll just go with it. So A equals 2. Huh. Combined mass of those. But yeah, but the 2 kilograms is like opposing the 5 kilogram thing. I guess we already accounted for that. I don't know. T is equal to mg plus ma. Is that just of one of these masses? I guess the 3 kilogram one, now that we know what A is? So we'd say 3 times 10 minus, because this A, I guess, is opposing gravity. 3 times 2, which is 24 newtons. Huh. Both masses are starting at the same time. I guess that's fair. All right, so yeah, Bode, it sounds like you just kind of wanted the answer. It sounds like it's 24. Thank you for the help, Lightning and Penbox. And Optimus was helping out too. Let's see, at Optimus. So I'm sorry that I didn't explain that very well, Bode, but if you do have a question about it, either me or someone in chat can hopefully answer it. I tried that Penbox and then I got confused. I think it's the most important part? Okay. So Bode also want to help with 12 here. Oh God. Yeah, sure. You're good with it? Okay. So this one, we have an evolved version of problem 10 here. We need to figure out T1 and T2. Is there more that should have taken that? It's been a long time since I've taken any sort of mechanics class, so I'm really bad with these. Yeah. Because we can still do the first part the exact same way, because that 2 kilogram mass doesn't affect the acceleration here. It'll change the newtons, I guess. You had 30 problems in 45 minutes on a test. Oh, geez. It's pretty intense, Bode. Okay, so T1 is the one on the left. Actually, they should be accelerating the same way. So the first step is going to be F equals, we're gonna do 5 times 10 minus 3 times 10 is my guess here, which is 20. And then we set that equal to MA. But M is the mass of the total system, which is 3 plus 2 plus 5 is 10. 10a, so we get 2 equals a again? Wow. Hey, Dexter. You have a final exam next week, BAC? What is BAC? Either way, good luck with it. Okay, and then things are accelerating at 2 meters per second squared. Now, T1 and T2 apparently are different here. How do we figure that? So on just T1, oh yeah, and Fenlock's tutors, and I think including in physics. So I think that's where Fenlock knows how to do problems like this. But yeah, no, I'm doing electricity magnetism reading group. It's that knowledge isn't helping me here though. I feel just as lost as I did when I started it, or before I started it. But can we say T1? T1 is going up because it's the lighter mass. It's going to be the mass of the thing is 3 kilograms. 3 times 2 minus 3 times 10, the acceleration due to gravity, which is, I don't think the sign will matter all that much. I think I should have flipped it. That's just like an instinct thing. 3 times 10 minus 3 times 2, 24 newtons. That's not the answer. That's supposed to be multiplying, not multiplying, subtracting. Oh wait, you're thinking we'd get 36 lightning. T1 minus 30n equals 6? Should it be plus, or am I doing something wrong? Maybe it should be, okay. For T1, the entire thing is accelerating up at 3 times 2 newtons. And you can break that down into a component due to gravity going down, which is minus 3 times 10 is equal to the net force. So yeah, 36 looks more reasonable. Or I guess, no, that's T1, not F. Okay. And then T2, then let's call B for the answer. Okay. So T2 we can get the same way, except it's 5, that mass? Yeah. So 5 times 2 is the net force, which we can say is also the force due to gravity, 5 times 10 minus T2. I don't know if T2 should go first. T2 should probably go first. So that's 10 plus 50 is 55. Does this simplify? I feel like I did something wrong there. It's probably 45 or... $50n equals 10. Oh, I just can't do 5 times 2. I said 5 times 2 is 5. 60. And then we want T1 over T2. 36 over 60. What is that? 6 over 10. Wait. 36 divided by 6 is not 6. 6? Wait. Yeah, no, sorry. 6 squared is... What? Do I know how to simplify fractions? Lightning has it. Oh, I did flip the sign? Ah, okay. Dude, my intuition for these problems is 0. Uh, 4. So yeah, 9 over 10. Okay. See, I guess the answer is 9 over 10, but... Thank you both for bailing me out on this problem. It would have taken me a lot more Googling to figure it out on my own. So yeah, but I guess B for number 12. Extra education moment? Yeah, exactly. All right, sleep well, Bode. Sounds like you've been working hard today. Did our build taught you this? Well, hell yeah. Sounds like he did a good job. Was it me that helped you? I mean, and you also could just like stayed quiet and lurked too, which would have been fine, but you spoke up and actually helped, so I really appreciate that. Kind of a bunch of new faces here today, which I appreciate. Have I done optimization? I've done optimization like you would have in like a single variable calc class. I learned a little bit like Lagrange multipliers as you learn them in like a multivariable calculus class. Other than that, not really. Like this is probably the hardest thing I did with optimization. If there are more questions from chat, though, I might go do a bit of studying. Simplex method? No, I don't know it. Oh yeah, Jed did have a request that I go back to my old ways of looking through Reddit and stuff for questions, but man, I just don't feel like it. I'm really excited about like especially the physics. I kind of want to pick prom out of the physics book. Like I'm just like genuinely having fun with these. The worst game in your life so far after 3 days. Oh geez, good luck, Abdus Salam. What is it on? Why am I scrolling down the old-fashioned way? Yeah, I dual stream to Twitch and YouTube. Unfortunately, because of Twitch, I'm not allowed to show the YouTube chat up there also, so the only way to see it is to open up the YouTube stream as well, unfortunately. Oh, yeah, that's you right there. Yeah, I wish I could show both chats combined at the top. I don't know what the delay is compared to each of them. They're both in like the minimum delay settings they can be on though. Actually, I can just show it. The settings that YouTube gives me are right here. You can do normal latency, low, and ultra low. And I have it on ultra low. So I don't know what's faster, YouTube on its fastest or Twitch on its fastest, but I have them both as fast as they can be, I think. What's up with this field of a cylinder problem? Yeah, it's really variable. Like sometimes YouTube is popping, sometimes YouTube is dead, and I assume it has something to do with just whenever the algorithm chooses to push the stream or not, which I don't know. I have zero clue how that works, to be honest. How come I'm doing magnetism? I just thought it would be fun. Optimist, and so far it's been a ton of fun. So yeah, this is Electricity Magnetism by Purcell and Morin, and it assumes knowledge of multivariable calculus. And setting up the integrals from this has been super fun. Abdusalam, you're doing math, physics, biology, philosophy, and English? Just high school ever since important so far? Yeah, that sounds intense. Best wishes, like that's... I take some big tests too. None, well, like I said, like the SAT and stuff, but I don't think they covered as many topics as that did. Integrals in physics? To me, that it makes physics go from boring to fun. Optimists, they are pretty difficult though. So I'm looking at number 11 right now. It's kind of cut off onto the second page. So, physics greater than dumb algebra. Consider half-infinite hollow cylindrical shell. Ooh. With radius r and uniform surface charge density sigma. What is the electric field at the midpoint of the end phase? Yeah, it doesn't make it easier. It makes it more fun though. At the midpoint of the end phase. There's got to be some clever Gauss's law thing. Gauss's law doesn't apply that cleanly though, because there is an end cap, I guess, on this cylinder, whereas a cylinder that's infinite in both directions wouldn't have a cap. So maybe there isn't some cheesy Gauss's law way. As at least know what to do in physics, you got to think differently. Yeah, the difference of mindset has been a little bit rough. Like there's some questions where they just randomly throw out like cubed and fourth terms just because they want to, basically. And it makes the math easier. It's like, why would you do that? But apparently it works. Dude, this form CB struggled pretty hard. Okay. Radius are uniform surface charge density sigma. What is the electric field at the midpoint of the end face? Well, I think we can break this down into rings. It doesn't feel all that different from stuff that we've done. Let's see if let's see if my intuition is right though. Gonna focus only on A here at first. Not even gonna look at B yet. Okay. So we got a half infinite cylinder. We are actually we should orient this thing upwards. We're interested in the electric field at the midpoint of the thing now. It looks like a weird eye right now, but I'm thinking we can look at an infinitesimally small ring, make the claim that the contributions in the x direction are going to cancel, and figure out what the y direction is going to be. Well, yeah. I don't know if I want to define y to be up or down here. We can say it's up, I guess. I'm going to expect a negative answer at the end, though. So, just one piece of this ring pushes like that. And we can form a right triangle there. So basically, we're going to make y go from 0 to infinity at some point. And the level of y this thing is at determines the type of right triangle we have. So I guess first off, we could say that a dq is equal to the circumference of the circle, 2 pi. Are we given a radius? R. Two pi r sigma d dy? Yeah, because that'd be the thickness of the ring. Okay. Or, I guess so. Yeah. Because sigma's an area. Or, you know, charge per area. So we want to multiply it with an area. And then I guess this hypotenuse is root y squared plus r squared, right? What angle are we going to call theta? I guess theta can be down here, so we get, like, theta would range from 0 to pi over 2? don't know if that's important yet, but we're going to want to cosine theta, and I think that's good. So a differential of the field in terms of y is dq over 4 pi epsilon naught distance squared times cosine of theta, and cosine theta we can do a sub on. dq is 2 pi r sigma dy 4 pi epsilon naught y squared plus r squared. Cosine theta is adjacent over hypotenuse. Adjacent is y. Hypotenuse is root y squared plus r squared. I think that's something we can integrate now. So like one of the weird things with physics is like you could do this like some triple integral in cylindrical coordinates. But normally what I've seen the book do is you just kind of geometrically figure out relationships between things, and you can usually skip straight to a single integral. But a triple integral will get you the same result. So that's what I'm kind of figuring here. The 2 pi and the 4 pi can cancel. We'll just separate the constants in the variables. R sigma 2 epsilon naught times y dy y squared plus r squared to the 3 over 2. That's not too bad to integrate. So r sigma over 2 epsilon naught integral from 0 to infinity y dy over y squared plus r squared to the 3 over 2. We can do a u sub here. So u equals y squared plus r squared. Du is 2y dy. R sigma 4 epsilon naught integral du over u to the 3 over 2. That integrates to r sigma 4 epsilon naught minus 2u to the minus a half. It's unsub. The minus 2 can come out front. One over root y squared plus r squared evaluated from 0 to infinity. That's r, not k. Oops. Two epsilon naught. Infinity, that thing's gonna come out to be 0. Minus, plugging in for y, 1 over r. Ooh, the radius of the cylinder doesn't matter. Sigma over 2 epsilon naught? What? That's like a plane, isn't it? Or it's like something similar to a plane. Yeah, I really have been explaining why this makes sense in my head, but it's just kind of started to make sense a little bit. The exact same as a sheet. Wow. Huh. I guess it's the same principle. It probably wouldn't be the same, like, you know, at other points. Probably just at that one point, but it's kind of crazy. So part B says, use your result to determine the field at the midpoint of a half-infinite solid cylinder with radius r and a uniform charge density rho, considered to be built up from many cylindrical shells. Ooh. So this is where the, like, this would become a, I guess this would be a triple integral. The last one would have been a double integral. So I have a feeling it's going to be as simple as integrating the thing we just got. But we swap out rho or sigma for rho, and we integrate from 0 to big R. I should try and justify that, though. You know, let's not just say that. I mean, you saw me struggling with the Pulley problem. I mean, I haven't checked my answer yet, to be fair, but I don't know. Even though like this is more complicated math that's behind it, I feel like it's easier when calculus is involved. I got part A correct. Oh, all right. Thanks for confirming that. So we're going to make the claim that how are we going to, I'm trying to figure out a mathy way to relate rho to sigma. Oh, sigma is just, or rho is equal to sigma times d like small r, I guess. Right? Rho is equal to no. D rho is equal to sigma. No, rho isn't changing. Why is this messing me up? Is it sigma equals rho d small r? That, I think so. Or, I have a feeling that I know the end result. It's just actually getting there. Like if I were to modify that, okay, I guess I have a really hard time saying why, but I'm getting the feeling that rho d small r, which is going to be our variable of integration, is equal to sigma. Because rho is charge per volume. So you multiply a charge per volume by an extremely small radius, and you will get a charge per area, is my rationale, I guess. And like, I guess dr would be like that. And that would give us a convenient integral there. Because we would get e sub y in this case is 0 to r rho dr over 2 epsilon naught, which is equal to rho r over 2 epsilon naught. I don't know if my rationale is right. I feel like that's just the answer. How dare you? Did you ages to puzzle this part out? Honestly, a part of it was I remember seeing physics and depression work out the electric field at the center of a hemisphere. But he realized he accidentally just did it for a hemispherical shell. And you're like, oh, well, you just take this and integrate it from 0 to R. So I was working backwards a little bit from that memory. But yeah, I feel, the more I think about it, the more solid I feel about rho dr equals theta, or sigma theta. I want to look at the book's interpretation of this. This is number 11. Just to make sure that there isn't some like crazy Gauss's law argument you can make too. What is this construction? Series of ring stacks on top of each other. That's the exact idea that I did. You can also calculate the field by slicing them into half-infinite parallel strips. Huh. Oh, really? I don't know. It does make intuitive sense to me that you could take the thing you just got and integrate it from 0 to R, but I feel like I've kind of my mind like my thought process like tainted by hearing that comment from physics and depression, I guess. Shell method moment. It's kind of a similar idea to shell method. It's kind of a different application, but we did just calculate the field due to one shell of a half-infinite cylinder, and then integrated each like a shell of each radius to make like a filled-in cylinder, which is also what you do, I think, in the shells method for like solid revolution. Have I done numerical integration? I did numerical methods class. I don't remember if we did integration. Yeah, I think we did. Like Simpson's rule and stuff like that. Only like basic stuff. Like I don't know anything fancy, but yeah, and you can like see the differences between like how quickly each of the different methods converge. Sigma over 2 epsilon naught. Okay. They get a very simple parameterization here if you use theta. Probably take you an hour? Oh no. Integrating over dq simply yields the total charge q in the ring. I think in some effect way every integral pretty accurately. Oh, really? I bet there's a ton of algorithms for it. I have no idea what this figure is saying, I'm going to be honest. The parameterization, it looked simpler, but it took a lot of work to get there, so I kind of like my thing too. I made the comment that my theta is going to be from 0 to 2 pi as well, because I remember the book doing like theta from 0 to 2 pi in another problem. It's a close-up of the figure above it. Wait. Oh, okay, that's... okay, yeah. Did I draw my triangle differently? No, I oriented my cylinder differently, I guess. It's all the same, though. String corollary of this is that if we cap the end of the cylinder with a flat disk with radius r and the same charge density sigma... Oh! I thought there was a cap. I just thought it didn't matter. And the field inside the cylinder just below the center of the disk is 0. Huh. The disk looks essentially like an infinite plane from close up. Oh! So it's like there's the field from an infinite plane just below the cap. But the field coming from the actual walls of the cylinder are also like an infinite plane, so you get perfect cancellation. Wow. It's kind of neat. And then for part B, if we slice up the solids under the concentric cylindrical shells with thickness dr is rho dr. Okay. So I wasn't crazy when I was saying that. Okay. It's neat. I feel like I'm starting to see the pattern with some of these field problems. It feels like the similar approach, just have to use some different geometry rules. Well, what's up with 12, I guess? These next two are 3-star problems. What was that one? A 2-star? Eee, okay. So, yeah, these problems they aren't easy. I think they're fun, but some of them are just ridiculously hard. And if you're just like coming to this cold like you probably are, this probably looks absolutely crazy to you. Intercept at any point on the symmetry axis at a position z relative to the center. Ooh, okay, that's like an evolution. So I got a feeling we got to split z up into z inside the shell and z outside the shell. Now a z inside the shell, it's not 0. We can't make it that easy. We might need 3 integrals, one for above, one for inside, one for below. Oh, it's gonna be... Huh. A particular z inside the shell where e equals 0. You think? Oh yeah, I can see that. Yeah, because I think there's going to be a transition point where for some part inside the shell, it's pointing up because the forces from like the bottom and the bottom parts of the sides are pointing up. But eventually, the further down you go on this axis, the top part of the shell is going to push down harder. I wonder if I assume we'll get that naturally. I hope we will, as part of whatever integral we do. I'm going to mess up the problem thing. You thought about this one for humans, so you haven't gone far in it yet? Let's crush it? Hell yeah. Okay, so the flat part is on the bottom. Just make sure I get the figure right. That's right-handed, right? Yeah. Okay, so that's the three-dimensional version. We probably want to consider the two-dimensional version, though. Just do the XZ plane. Okay, so we've got I think we can split it up to be z less than or equal to 0. 0 is less than z. Is less than r. I think I'm going to make the claim. Well, I'm debating whether that should be strictly or equal to. What do I want to do with the borderline points, I guess, for 0 and r? Maybe for the integral. No. I won't say it doesn't matter. I think those are separate calculations, to be honest. Although z equals 0, I think was given to us in an example. I could see this being inclusive. The more I think about it, because the very tippy top of the hemisphere is hardly going to matter. It's going to be about the same as a point just barely above the hemisphere, I would think. So maybe we can say this. I don't think the same argument applies to the bottom, though. So where do we want to start with this? Maybe let's just start with z less than 0. Just go in order here. So let's just do two-dimensional impression. That'll make it more. That'll make the geometry a bit more clear to me. We take a z down here. We have to worry separately about the force from the bottom and the force from the field, I guess, from the top. And then we can make a symmetry argument with rings, I guess. We can calculate just that bit. So could we actually do both these calculations at the same time if these angles were the same? I don't know if it'll actually save that much work, but so the distance from here to here oops, wrong color. Is root z squared plus x squared. And you know what, honestly, I think I want to I have a feeling it might save work if we keep these angles the same. So if we go through this point, we can keep going at the same angle to also hit every part of the top of the hemisphere. That red distance is going to be root z squared plus x squared. The blue distance is going to be that's a circle, I guess. C equals root r squared plus x squared. I guess it's the issue is this is going to vary. God, there's already some weird geometry happening here. I think I was assuming that there is no bottom. It wouldn't be much of a hemispherical shell if there was no bottom, I think. Or, oh no, is there? Oh no. You might be right, Fembox. I don't know if E would be 0 inside everywhere. How... See, they actually made the point there wasn't a bottom to that half-infinite cylinder. Like, there was no cap. So I think you're right. There probably isn't a bottom. Which is really vague to me, because I would think... Because if you have an entire hemisphere, you do have a bottom. So I would think that a shell of that hemisphere would also have a bottom. I guess you only get the bottom if you were to integrate that shell. Okay, that's an annoying... I think you're right, Fembox. And that does simplify things a little bit. See, that does mean we only need to worry about one distance. That distance isn't the easiest thing to actually calculate, but it may not be that bad. So that distance there, we do still have the same hypotenuse. I think we want everything to be in terms of z here. How do we get... Oh, maybe, is it just distance formula? Maybe that's the best way to go about this. So this formula implies that... I shouldn't have written with the square root. Sorry, we want x equals. We want to eliminate x. R squared minus z squared. That's not quite... Technically plus or minus, because only the positive root would be only the right side of the entire circle. This gets the entire circle, which isn't good either, but... What am I doing again? The distance from a point 0z to a point so minus root r squared minus z squared, comma, a different z is the issue. That's okay. How do you get this distance? Why is this? Because this z is different from that z. Oh. I'm gonna sit down for a second and get some water and think. I think the z less than 0 component will become easy once we can figure out how to compute this. Distance from a point to a circle. I'm thinking about trig. Like if we called the angle between the z-axis and that red dotted line that I drew theta, we know the top of that right triangle is x. I don't know how we vary theta. Like what would theta range from though? It depends on z. That puts us right back where we started, I think. We can take z to be fixed for the sake of this. Oh. Like if we made the point on this hemispherical shell, x1 z, or like I guess x2 z2, and the point on the bottom underneath the z-axis to be like, 0 comma z1, we could apply the distance formula there, but then we end up with something with z1 which is fixed and z2 which is a variable. And I guess that's actually a good thing because we need something to integrate over. Maybe it's better. Huh. Is there like a spherical coordinates thing that will make this calculations simpler? Because I'm doing things with Cartesian, and that may not be best. Even cylindrical might be better, to be honest. Man, there's so many different ways. I feel like the more I think about it, the more there's like a lot of different ways that we can do this. I'm leaning towards cylindrical a bit more now. Because it is convenient with the z variable being the same with cylindrical and Cartesian. That doesn't necessarily help us get at that distance, though, does it? Like, how do you find the distance between 2 points in cylindrical coordinates? I feel like you just convert them to Cartesian. This is gonna bother me. I feel like I can do this problem. It's like it's a 3-star problem, and I feel like that's pretty accurate. These difficulty ratings go from 1 to 4, 4 being the hardest, and the 3-star problem I tried kind of felt similar. Where like I feel like I know how to, or like, I feel like I know that I can do it. I'm just getting tripped up on how. I feel like they're gonna say something stupid for like for z much greater than r. You can approximate it with a circle or something. That's not really valid for z less than r. Like they didn't want you to get it for every z. It might be, ooh. I might be making this too complicated. Because we can get the distance, the distance from the hemisphere to the origin is r. So if we took like r cosine theta or some variable from the z-axis, we could just do that plus z. Is that it? Erase this yet another time. If we name this angle as theta, we make this right triangle. That distance there is r cosine theta. And then, without having to think too hard, you could take the distance down here as z. So the total distance is z plus r cosine theta. And then theta would vary from 0 to pi over 2. I think I should call it phi. No, I'll call it theta. It's more like an azimuth angle, and I was taught to write those as phi, but I think the physics book uses theta for that. This feels like something, I guess. Okay, so one of these rings then has charge dq equals I guess 2 pi small r sigma dr. R. And so that means that is a little r up there. Okay, construction. I don't know if it's important to name that smaller, but I sure did it. Well, yeah, we need that smaller. Small r, however, is equal to, we can Pythagorean, well, I guess we want to do trig. 2 pi, well, just sine is opposite over hypotenuse. So sine theta is little r over big R. So little r is equal to big R sine theta. So dr is equal to r cosine theta d theta. I feel like I'm constructing something here. 2 pi, so setting that r for r sine theta, and we're also going to set the dr for r cosine. We're going to get big R squared sine theta cosine theta d theta? Huh. Sigma. Drop the sigma. Don't drop your sigma. It's important. This feels like something. It certainly doesn't feel like nothing. Could we say that the electric field in the z direction in this situation, well, I guess dE, well, electric field in the z direction is equal to the integral of dEz, which equals the integral of dq over 4 pi epsilon naught I'm still having issues with the distance. That's my issue. I said that z is equal to r plus cosine theta. I think that might still work. Can I just blindly plug that in? It's not dependent on x or y, which is what I was trying to think through. I think it's okay to just plug it in like that. And we figured out what dq is. dq we can write in terms of d theta. In theta, we're going to vary from 0 to pi over 2. 2 pi sigma r squared sine theta cosine theta d theta 4 pi epsilon naught z plus r cosine theta squared. This might be right. I don't know. I guess we'll follow it through. Sigma r squared 2 epsilon naught 0 to pi over 2 sine theta cosine theta z plus r cosine theta squared d theta. All right, so if I took, do I want u equals, I guess, r cosine theta? How does it look after this? So is that dq based on a horizontal ring of charge? Yes, Benbox. So yeah, I'm breaking this hemisphere up into horizontal rings of charge with a radius small r. I feel really sketchy about what I've done here, but I don't see where I went wrong, if I have gone wrong yet at least. So we divide by r because of that. We're also going to divide by r because that's just cosine theta, not r cosine theta. So I think that r squared cancels entirely. Drop the bounds for now. Okay. Oh. Well, we can save ourselves some work, can't we? If I did this instead. So we get just u squared on the bottom and u minus z on top. And that's easier to integrate. The ln makes me nervous. We're gonna get ln of 0. Oh, do not tell me. Oh, no. We won't. We have to unsub and then I think we'll be okay. Okay, from 0 to pi over 2, what does that come out to be? Cosine of pi over 2 is 0, so we get ln of z plus 1 minus, now with 0, ln r plus c plus c over r plus c. Is that good or bad? I don't know. Hi, ln c over z Those are numbers, or letters in numbers. I don't know what this means, to be honest. The farther away we go, the higher z is, the more we get ln of just r plus 1 over r minus 1. I don't know. I have no idea if that's right or wrong. I wonder if I can look at the answer without seeing the wrong part of the answer. Because doing the next two parts of the problem, I think, are going to be equally challenging. Well, maybe above the hemisphere is really similar, but it's z minus r cosine theta. And I think everything else is the same thing. So that might not be so bad. What is it inside the hemisphere, though? That's the tricky bit, I think. It might not be, okay, I have part of an idea for inside the hemisphere. Honestly, I'm just gonna say for z greater than 0, same, but with z minus r cosine theta. I don't feel like going back through all this work and getting a slightly different looking answer. Like instead of doing this for the distance, or z plus r cosine theta, we do z minus, or sorry, yeah. I'm getting more interested in the part inside the hemisphere. Let's do our same 2D projection here. So if I choose this as z, we've got to sum the contributions from the upper part and subtract out the contributions from the lower part. And I guess since positive d points up, or positive z points up, we can take the blue part as the positive part. So we do have the same ring construction that we can make here. I think this math is, yeah, I think this math is all valid here for this same situation. The thing is, we want to integrate in terms of z, ideally, not in terms of theta, I think. Because theta here is kind of tricky to define. Right? It's the same definition, but it's hard to relate to z. So maybe we actually want a different theta. We might want to redefine theta. So if I think about, if I define theta from this point z, rather than the origin like I was doing before, we could do one from like, you know, the right integral could be 0 to pi. The blue integral could be pi to 2 pi. Well, no. If we're doing rings, we only do about half. So we could do 0 to pi over 2, and I might be able to work out what that theta is down to the x-axis based on r. Yeah. Okay. So 0 less than theta over 2. Our rings. So we can still define two, I think, so with 2 pi r sigma dr for a horizontal ring, but, well, what is r? R was basically my old theta. This is a new r. No. I think it's okay. Is it though? This portion is r minus z. So we can use trig to relate the small r to big R minus z, which is tangent big R minus z tan theta, which means dr is big R minus z secant squared theta d theta. So this thing is 2 pi sigma, we get R minus z squared tan theta secant squared theta d theta. Oh, we still have z. Well, z we're taking as fixed. So integrating this with theta is not so bad, I think. Yeah, u equals tangent theta. First, I know you got the formula for dq. It's not only work for a flat disk. It works because of how I'm accounting for theta here, Fenbox. Like I'm making sure that r is not constant, whereas like for that cylinder one, r would be constant. I guess flat disk can cut into rings. I have a feeling it's okay, but again, I have a hard time describing why. Like, I would have loved to look at the answer key to verify the thing I did over here. I don't want to look at it yet, though, until I go through with this calculation. But I think by the way that I've constructed it, it's okay. Yeah, I'm just gonna say it's okay at least. So all the stuff that, really? Also I just did here is related to the red part of the hemisphere. The blue part of the hemisphere, I don't even know what this angle is here. You know that that's Z and that's R. So the angle and we want the angle from this hypotenuse up to like the parallel part to the x-axis. So we can do pi over 2 minus z over r. That's not, no, that makes no sense. It'll be arc sine z over r. And is that okay? I'm really doing stuff that I can't explain here. You feel like it's not okay? You would want to put money down? Yeah. Dude, I like, your guess is as good as mine here, I guess. So we're gonna call that bit there r, small r. Whoa, 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 whoa. I am smoking something. This distance is not big R. That distance is big R. So we want to do 90 degrees minus arctan R over Z. That looks much better, and certainly not equally as random. Wait. No. Dude, I'm crazy. What? Where does big R come into play? It's only big R at the very bottom. It is smaller. It just happens to equal big R at a certain point. But, like, what the hell, dude? I don't always know the distance from this point to the bottom part of the hemisphere, do I? Like, huh. Plus, that distance isn't always z either. Okay, this is... The blue part is harder than I thought it'd be. if I'm defining, God. It's probably slightly better if I draw my right triangle different. Like, I guess the right triangle that I'm really interested in is like that one there. Because I'm really interested in like the angle that's right there. I was doing pi over 2 just so I could flip the triangle, but I need more water. Okay, we're taking z as fixed. The height of that triangle is still changing though, which is annoying. How do we... Like, we just have like very little information about the blue part. Well, I mean, we do have information about it. I just don't know how to express it. Okay, I really want to know if the little thing that I wrote on the right is right. I can't figure out the left part, the blue part. I'm gonna take a little peek at the answer and not, and hopefully I'm just gonna hope that I can look at just barely enough to verify the part that I did, and I would feel happy and think more about the last part. But if I do spoil the last part, it's a price I wanted to pay at this point. I'm getting tired. It's number 12. Okay. Oh, law of cosines. Oh, do you not have to split up into 2 separate parts? Does the cosine theta take care of that for you, too? Oh my god, I would never have thought drawing that triangle? I think that you don't have to split them into 2 separate things with this. dA is 2 pi big R sine theta. Why? Wait. Yeah, gold. I'm just starting to peek at the answer to this problem with calculating the field due to a hemispherical shell at any point on the symmetry axis. So I'm looking like just barely at the solution and trying not to scroll down too much. I got like potentially part of the answer and I wanted to check that, but the answer starts off with doing the part that I like got stuck on, so. Uh, 2 pi big R sine theta. Big R. Oh, that's the okay, yeah. And RD theta is the thickness of the strip. Okay. So, okay, let's not look at anymore. Let's go back to the problem and try it from there. Oh. You got a god awful nigger in like number 8? Okay. Yeah, forget everything I thought I knew about this bogus idea. There's probably a law of cosines application here too, wasn't there? I bet I got this problem wrong because I should have used law of cosines. Now I want to do the problem. Yeah, I'm probably gonna want to redo that part from scratch now that I. At least have this start. We don't even. I wonder if that restriction is even necessary here. Just keep it though. Oh yeah, I think it is. So that is Z. It's going to put in the XC plane for a simple drawing. Okay, so that's big R. That is Z. This is theta. And we're interested in the three-dimensional horizontal ring that's around there at that point. So by law of cosines, well here, let's say dq is equal to sigma 2 pi. So the radius of that horizontal ring is big R sine theta. And the thickness of it is RD theta. Does this match? Thank God it's screwed about your whole life, yeah. So I wrote law of sines and law and cosines in trig, yeah. Dude, I never think about them, and it's coming up a lot here. You forgot the second R? Yeah, this one always trips me up because it's the formula for arc length, and they just kind of use that to approximate straight sides too when theta is small enough. That's how I've been interpreting it whenever I see an R d theta around. So is this thing valid for 0 to pi over 2 for theta? I don't see why not. So E sub z is equal to dE sub z is equal to 0 to pi over 2. dq is this thing here over 4 pi epsilon naught law of cosines. It's going to be squared at least. Z squared plus R squared minus 2ZR cosine theta. Okay. Is this integral that bad? Don't we just do u equals this thing? Two ZR cosine theta d theta. You forgot. Okay, yeah, that's not a new message. Okay, so u equals z squared plus r squared minus 2zr cosine theta. du is plus 2zr sine theta d theta. So the sine thetas cancel. We get a z is a constant. So we can do that r cancels with one of those r's. 2 epsilon naught z. Well, we have another 2. So 4 epsilon naught z. Saying epsilon naught and then z makes me say something that I probably shouldn't be saying. If I say it too quick, I guess. 1 over u du. So we do get an ln, interestingly. I wonder if my work on the right isn't so bad. Maybe it's the hard way. Cosine of pi over 2 is 0, so we get ln z squared plus r squared minus cosine of 0 is 1, ln z squared plus r squared minus 2z r cosine theta. Oh, not cosine theta. Probably don't need the absolute values, but keep them. Is that the answer for the inside? That seems like something, I'm sure. You know what? The formula for outside won't be that much different. I do think my thing is wrong. It should look a little bit different. Let's see if we can look at the answer key again and see if they start with that inside part, let's see if we can verify just that inside part. What page? Like 580 or something? Oh no. Do I need another sine theta? Is that why this is a terrible integral? Oh. I forgot. Ah. F. Dude, I'm getting to, I can't think anymore. I need to take a break from this one because I need to tear down my work again. It's everyone's crap. Like I am gonna do this problem, but like, ugh. Yeah. Don't show me any more of the answer. I'm gonna figure this out. It's too freaking hot. Purcell wins this round, but not the war. These 3-star problems, I don't want to know what a 4-star problem is, dude, at this rate. There's a lot that's going on with these. 3 stars means do not attempt. 4 stars should come with like a mental health warning. But anyway, I think I'm gonna turn the YouTube stream off here because I'm probably gonna wrap the stream up. So if you're here on YouTube, I appreciate you. I'll be back on YouTube on Saturday. Today is Thursday, last I checked. So yeah, see you, YouTube.